Yeah, really. Then they'll listen to it and go, huh? Okay. This is worksheet 3. What is the definition of I? Okay, now my cursor's not working. Okay. It says the imaginary unit, I, is defined as the principal square root of -1. So, really? We're going to go there? Okay. Square root of -1 is I. So if I have an I squared, it's the square root of -1 times the square root of -1, which would become... Okay, be careful, but everybody understands that? Square root of 5 times square root of 5 is 5, right? So square root of -1 times square root of -1 is -1. All right, if we add another one, I to the third, this would be -1, right? Two of them is -1. This one is an I, so we get -I. Everybody all right? The next time we add another one, and we have I to the fourth, well, an I times an I, you told me was -1. Another I times another I is another -1, so we get +1. If I throw another I on there, I to the fifth is going to be 1, the last thing we got, times another I, right? It's going to repeat. There's only 4 possible solutions when you have powers of I. It says the first 8 powers of I are shown below. I to the first is I squared is -1. I to the third is -I to the fourth is 1. Okay, those are the only 4 possible answers for a power of I. The pattern repeats after the first 4 results. In general, the value of I to the n, where n is a whole number, can be found by dividing by 4 and examining the remainder. That's a magic trick to me. I'm not going to teach you a magic trick, okay? I want to teach you something that makes sense to you. I hope I can make this make sense to you. All right, powers of exponents first of all. Does everyone understand that that's actually x to the what? 13. Yes? This is a 12, and there's another one over here that's 13. We're all good? X to the 13th. Okay. Now we're going to go to this question. I to the 53rd. That is really blurry for my old lady bifocals, so I'm going to write it bigger here. I'm going to divide that by 2. What's 53 divided by 2? Well, what's 52 divided by 2? 26. So how many i's do I have so far? 2 times 26 is 52, right? I'm going to throw one more on the back. Now I have 53. Are we good? Okay. I cannot remember the crazy rules we just went over about I, -1, +1. Okay? But I can remember in my little pea brain that I means I, and I squared is -1. Can I remember those 2 things? If that's all I have to remember, I'm good. Okay, so I squared is -1, yes? What is -1 to an even power? -1 times -1 times -1. Everybody good? That it's going to be +1? Nobody's confused? So what did that all simplify down to? I. Now, some of your calculators will do this if you put it in the right mode and you type it all in, but a lot of the calculators won't do this, especially when you get to a really high power, like I have down here, I to the 279th. None of the calculators will do it. It uses this weird, I don't know that I want to record this because I'm not sure I'm saying the right, I think it uses what's called de Moivre's theorem to come up with an answer, and it gives you this crazy business, okay? But I don't remember if that's the right theorem. We're going to try this guy next. What does this say? I can't even read it. Does it say I to the 86th? Okay, so here's my second example. I to the 86th. I'm not too smart. I can only remember I and I squared. So I'm going to break this into I squareds. How many I squareds are there in 86 of them? If I break this apart, that makes 86, right? Because you multiply the exponents, okay? What was I squared? -1. And -1 to the 43? Okay, so I to the 53 was I to the 86 was -1. Now we're going to try this ginormous one right here. My notes aren't very clear. Let me put a line right here. Yeah, that's a straight line. Okay. Try this. I to the 279. Because calculator won't do that no matter what. Okay. I can only remember powers of I or I squared. There's going to be a leftover, yes? So let me remember to put that one on the back. Okay, 2 goes in here, 138. Anybody? Okay, so 2 times 138 would be 278. One more is 279. What is I squared? To the 138th power? What did I do wrong? Is it wrong? Oh, this should be 139. Guys, you got to catch me on these things. Definitely not, but yes, I did divide wrong. This is 139, right? Now do I have it right? Yes? Okay, thank you for checking. Times an I. What is -1 to an odd power? Times I, which is just also written as a -I. I don't care which one you write. Okay, so far I got a -1, an I, and a -I. There's one more possibility. If I had, I'm just going to make an easy one, I to the 24th, it'd be I squared to the 12th. Everybody okay? 2 times 12. And this would be -1 to the 12th, which would be +1. That's the only other possible answer, okay? Now, all of those fun examples, and I'm telling you now, there'll probably be one question on the summative, okay? This is not the be-all and end-all of complex numbers. You're not going to do this for the rest of your life every other day. You're going to find powers of I. This is true. I guess you could get a degree in imaginary numbers. I think I have such an imaginary degree. I wish they paid me based on my imaginary degree. All right. Sums of real numbers and complex numbers, number multiples of I, belong to an expanded system of numbers known as complex numbers. So, an imaginary number is like, pure imaginary number is like 2I, has an I, with that's it, something times I. All right, when we add a real number like 7 and we write 7 plus 2I, this becomes what is known as a complex number. Anything that can be written in this form can be called a complex number. If you happen to write 0 plus 5I, that would really be called a pure imaginary number because it doesn't have a real part. If you wrote 9 plus 0I, that would really be called a real number because it doesn't have an imaginary part. But basically, anything that can be written in this form is called a complex number. Are we good? If it has an I, we usually just call it imaginary number, but it can be called complex because we can add a real part onto it. You remember these from last year? These are the easy ones, guys. You just treat the I like a variable. So 5 minus 3I plus -2 plus 4I, you add the like terms and get, anybody? 3 plus 1I, or 3 plus I, we okay? 5 and negative 2 is 3. Negative 3i plus 4i, adding like terms, is 1i. If you wrote I plus 3, I'm not going to count it wrong. But they will always write their answers in this form. Just like if it's x squared plus 6, we always write the x squared first normally, but it's not wrong to write it the other way. Well, complex numbers are always written in that order, that form. All right. This is the one people mess up. What do you think? Yeah, you got to distribute back here. And if I don't write it down, I'll get it wrong. You can either distribute the negative or you can just rewrite it. Nope, not like that. Minus 14 plus 6i, right? Because you're distributing that negative. So you end up with what? Nice job. We good? That's all I'm going to do is one of each of those. So when you do a couple more on your homework, we'll be good on those, right? We added, we subtracted. Now we have to multiply and divide. Okay, multiply first. Because there's two terms, a plus bi form, when we start multiplying, we have to multiply everything, which is double distributing, or our favorite word, FOIL, from Algebra 1. Okay, so we can handle this because an Algebra 1 student can do this. It's all Algebra 1 until the end of the problem. Okay, 2 times 7 is 14. 2 times negative 4i is negative 8i. Negative 3i times 7 is negative 21i. That's why I write my i's different than my ones, because I want to make sure that looks like a 21i. Right here, this times this is a plus, right? Because negative 3 times negative 4 is positive 12i squared. Okay. If you want to go ahead and combine like terms, I usually don't at this point. Because what's this going to trade out to be? Negative. I squared is negative 1. Everybody okay? So 12 times negative 1 is going to make that a negative 12. So all that became a negative 12. So now, if I waited till now to do my like terms, there's actually 2 real parts that add up to 2, and 2 imaginary parts that make negative 29i. So my complex answer in a plus bi form is 2 minus 29i. Did someone else get that, or did I make a arithmetic mistake somewhere? We good? Okay. Can you try this one on your own? You guys can work on the bookwork if you want, if you get all this. What's going to happen here? Okay, the middle terms cancel, and what happens to this guy back here? Turns into a positive 25, because the I squared was negative 1 times a negative 25 becomes positive, so we end up with 41. Okay, this is a very important concept, what just happened here, because what we multiplied together with imaginary numbers became a real answer. That becomes really important when we have to do some crazy business with rationalizing denominators in a minute. The term for these two, for plus 5i and for minus 5i, okay, are called complex conjugates. Two complex numbers in a plus bi form and a minus bi form. What changed signs, guys? Only the b, right? You take the opposite of the b term, the a stays the same. Those are called complex conjugates, and they can be used to rationalize imaginary denominators. Does that just sound fascinating? I'm going to rationalize my imaginary denominator. That's a lot of syllables right there. Okay. Back at some point, you had to rationalize this because some evil math genius decided it wasn't okay to have a square root in the denominator. Now, We want to square this. I want to square that and make it 4/7 because that sounds nice. I can't randomly square a number. If it was an equation, I could square both sides, but I can't randomly square a number. The only thing I can do to any number is multiply it by 1, because 1 doesn't change anything, right? The way to make this a square is to multiply it by itself, so I have to do to the bottom and the top. That's why we do that. I know you just memorized that at some point in your life and didn't really understand it. This is a form of 1. We're allowed to do that. Square root of 7 times square root of 7 is square root of 49, which is 7, and we end up here with 2 square roots of 7. Did you really know why you did that before? Now does it make a little bit of sense? Okay. Okay. So now when we have 3 minus I over 2 plus 5I, guess what that I represents? Represents a radical, right? Square root of negative 1. So the same evil genius who decided we couldn't have square roots in the denominator said we can't have imaginary answers in the denominator either. Okay. We want to square that denominator, but actually squaring the denominator wouldn't help, so I'm not going to go there right now. But what did we do earlier that made something into a real number? The complex conjugate. So 2 plus 5I is going to get multiplied by, what would the complex conjugate of that be? 2 minus 5I. Remember, you only change the B sign. Whatever you do to the bottom, because it has to be a form of 1, we have to do to the top. Is your brain going to explode yet? You don't want to write this one down. You don't have to. I don't know if there's room for it. There probably is. It's got plenty of room there. But, okay, I don't have much room. I need to FOIL the... Let me see if I slide this down a little bit so you can see in the back better. But if I FOIL the top together, somebody help me. 6 minus what? And then a minus 2I, and then a plus 5I squared. Am I going too fast? We okay? All right, I'm going to leave that alone for a second. Do the denominator for me. 2 times 2 is 4. The whole point of this was that a minus 10I and a plus 10I were going to cancel each other out, right? Here and here. And then a minus 25I squared. Did I do something wrong? Or are we okay? All right. The good news is these are going away. What's the other good news? Those I squareds are going to make themselves into negative 1s. So this is going to be a negative 5, and this is going to become a positive 25, right? So are we okay if I don't rewrite that and you get that that's a negative 5? That's a really big negative sign right there, okay? So 6 and a negative 5 is 1. Negative 59 minus 2I is negative 17I. And what is this all over down here in the denominator? The only things left are 4 and 25, so we have 29. Okay. You know how laid back Hofbauer is, so Hofbauer would accept that answer. But that is not actually A plus BI form. Does anybody know what A plus BI form would look like? Because A is 1/29th, right? And B is 17/29ths because they were both over 29. Or B is actually negative 17/29ths, but we won't worry about that. This is proper form. The only reason I stress that, guys, guess what? On the ACT, what are they going to have it in? On the SAT, they're going to have it in proper form when you look for the choice, right? Okay. Let's finish our examples here. This one isn't even written correctly. We need to write it above each other. At least I do, or I'm going to do it wrong. What are we going to multiply top and bottom by? Complex conjugate, which is 1 plus 2I. Good call. Okay, guys, start foiling and see what you get. I'm trying to fit this up here so I don't run into the next question, and I'm writing really small. Anybody figure out what the top is? That's what I got. Did anybody else get 11 plus 7i? Did I do too much scribbling on top of scribbling there? Let me rewrite it. It would be 5 plus 7i. This, oh, that was a minus, wasn't it? I didn't go back far enough. Sorry. There we go. Woo! Too far. All right. So the top is a 5 plus 7i, and a minus 6i squared becomes a plus 6. The denominator is a 1. These i's canceled out. Minus 4i squared becomes a plus 4. So that's where we ended up with 11 plus 7i over 5, or each part over 5. Guys, don't write 2.2 plus 1.4i or whatever the decimal equivalent to that is, okay? Use fractions or whole numbers. All right. I can show you this example right here, and I can, what's different about this denominator? Anybody have the vocabulary? This denominator is what kind of a number? It's a pure imaginary number, yes. You could multiply by negative 7i top and bottom. If you do that at the end of the problem, you're going to have to reduce everything by 7. It's going to reduce by 7, okay? All we really need to multiply by is another I, top and bottom. It would work, I promise, if you did multiply top and bottom by 0 minus 7i. But if we just multiply by an I, what will happen to the top? Distribute the I on top and we get 2i plus 5i squared. And in the denominator we get 7i squared. Okay. What does that top become? 2i minus 5, and the denominator becomes negative 7. Can somebody restate that in a plus bi form? Yeah, that's the proper, I'm not super picky, you all know this, but that's supposed to be a 7. This was a negative and a negative, that's where it became positive. Okay, did I lose anybody? Lots of rearranging. And I wrote crazy. I went from here to here to here. That wasn't a good plan, but okay. Next part, if you haven't been paying attention because you think this is too easy, please pay attention to this question right here, because it is super easy, but it comes up on the test and everybody gets confused. It looks super hard. 2a plus 5i equals 6 plus bi. Do you not see 3 letters and 3 different numbers? I'm totally confused, right? But it says, given 2 equal complex numbers, the real parts have to equal the real part. And the imaginary part has to equal the imaginary part. So, what's the only thing with an I on the left side? On the left side is a 5i, right? What's the only thing with an imaginary part on the right side? bi. So guess what? b equals 5, just like the girl said in the back. Is that Besma? All right, what about the real part? Real part over here is a 6. The only thing that doesn't have an I over here is a 2a. So a has to be... Okay. Is that not the easiest thing ever? Okay. We decided we need a 1,000-point assessment on this concept on Monday, okay?
Fantastic idea.
Yeah, I'm not going to happen. Sorry. I don't really like how this one is written. I would have moved the I to the end. It just feels right to me to have it be yi instead of iy, but it doesn't matter. Okay. So real part's a little bit easier this time, right? 12 on the left, 3x on the right, so x is 4. Imaginary parts, we have 7y, I has to equal 21i. If we get rid of that, so 7y equals 21, y equals 3. Okay. I know it seems really easy now, but when you get to those questions on Wednesday night, because this homework check is not due till next Thursday, look at your notes, okay? Then you'll remember it was easy. Last problem is an application. They actually do use eyes besides these kind of eyes. They use eyes in electrical work, in electricity. Electrical engineers have to use this. I don't pretend to know enough about it to know how it's really used. I do know, as we've seen a minute ago, those eyes look like ones sometimes when you write them and you get writing, right? I don't know for sure why they use this, but they don't use I's, they use J's in electrical engineering. That means the same thing, okay? But when they do it, they use J's. Somebody suggested it had to do with joules, but I don't think so, because I think it's a label. Joules is a label. And this is not a label, it's a number. So, anyway, it says the voltage E, the current I, and the impedance Z in a current are related by E equals I times Z. Find the voltage in volts of each of the following given the current and impedance. There's only one example here, but I know nothing about any of this, but I look up here and I go, oh, hey, they gave me a formula, and they want me to find the voltage. I have an I and I have a Z, so what does it look like I need to do? Multiply. It says E is equal to I times Z, so I'm going the I here. I can't decide if I'm going to make it I or J. There we go. Must multiply by the Z, which is this. Okay, you can write it as I's, I don't care. We multiply it together, which means we just FOIL. And I can't write it as J, I just want to write I. Okay, and we're going to still replace the squared back here with a -1. So I end up with 7 plus 16J plus 15, which is 22, yes? Did I do something wrong? We're good? Okay. If you wrote it as an I don't care. They use J. We're not really done. It's an application problem. Can you give me a label? It says find the voltage in volts. Okay. Does that seem pretty doable? I didn't really teach you hardly anything today, really, right? You all knew all that? Hopefully you've seen it all. It was a good, easy Friday lesson. This is the assignment. It is written at the bottom of your worksheet. Did everybody see it there at the bottom? Because I didn't bother to put it on the board, I just wrote C worksheet 3B for the problem numbers. I didn't want to write them all down. I'm lazy.